Okay, so this unit we are going to talk about, first off, how information gets from outside to inside. Okay, we're going to talk about sensation. We're going to talk about how our different senses work. Um, I'm not going to lie, part of this unit is kind of boring. The biology part is kind of boring, where we talk about where you're going to have to learn the structure of the eye, structure of the ear, like that sort of stuff. Not the most exciting information in the world. Okay, but it is kind of the last little bit of biology. We have a little bit more later on, but not a whole lot more after this unit. Okay. The part of this unit, though, that is really, really interesting is the part where we talk about perception. Okay. Our understanding of the world. This is where we are going to get into the really conceptual. We're going to start getting conceptual with psychology. And it's not just going to be this kind of like objective black and white. Okay. We're going to be talking about how we think about things. Okay, so let's see. One of the big things in this unit with perception is how sort of our brain, perception is how we understand the world, and how our brain sort of creates the understanding that we have. So I want you all to look at this real quick. All right, this is called a lilac chaser. And what I want for you to do is stare at the center cross on the screen right here for about 30 seconds. And I want you to see what happens. Anybody notice anything interesting that happens when you stare at it for a little bit? All right. The little purple dots start to disappear. Anybody know why? Anybody have a guess why? That's part of it. Yep. All right. They keep moving. Yeah, because we're not focused on it and it's in our peripheral vision, which is on the edge, our brain basically decides we don't really give a crap about this anymore. And so it stops paying attention to it. All right. Does anybody notice anything else that happens? All right. Did anybody see as the purple disappears, the light's moving to? This is called phi phenomenon or beta movement. This where it turns green. Anybody notice that? Anybody know why that turns green? Sort of. Yeah, but anybody know why the pink or the purple would turn green? Yep, they are what are called opponent colors. And the way we'll talk more about this later on, but that's called an after image. And after images occur when you stare at a color for a while and then you look away from it, you will actually see the opposite color. All right. Your brain basically creates, but there we have certain neurons that do this, but your brain will see the opposite color in the negative after image. And that's what you're seeing there. Okay. Purple and green are opponent colors. All right. So we'll get more into that. All right, this one doesn't really work when you're up close. Which one's bigger, A or B? All right, B's bigger. Who says B? Who says B's bigger? This is a lot easier to do when we're actually in class because we can. Okay, who says that they're the same size? Right? Who thinks that B looks bigger, but also thinks that this is an optical illusion and they are both the same size? Yes. Yeah. Okay. All right. Our brain, because we see this as a continuous line, we see it as just kind of one thing. All right. And so we perceive B as being bigger than A. They are in fact the same size. If you move B over so the top corner was in line with where A was, they would look, you'd be able to tell that they're the same size. Okay. All right, that's just an impossible figure. All right, so sensation and perception. Sensation, all right, when we talk about our senses, sight, smell, touch, balance, movement, taste, okay? When we talk about all of those, that just refers to the information that is coming in to our sensory receivers. Okay, that refers to light waves that are triggering photoreceptors, rods and cones in the retina. That refers to sound waves, right, bending hair cells in the cochlea, touch signals activating activating proprioreceptors in the skin. Okay, sensation is the process of information getting to the brain. Okay, it is objective, meaning most of us, all right, for most of us, we are all sensing the same things. Okay, we're getting the same light waves. If you're in the same area, getting the same light waves, same sound waves, blah, blah, not entirely the same, but like sensation is just the information that is coming in. Perception, though, is our brain's way of making sense of that information, which is why two of us can eat or smell something. Let's say that somebody made Indian chicken tikka masala, okay, and like tikka masala smells delicious, all right, but that's my personal opinion on it, all right. I could smell it, and Griffin could smell it, and I may like the smell, and Griffin might hate the smell. We're both smelling the same thing. It's just our perception of the smell. All right. So I don't know why this isn't working. Perception is subjective. It is our brain making sense of the information coming in. And we're going to talk about how both of these work and how they work together. Now, I want you to look at this is called Adelson's checkerboard. And I want you to look at square A and square B and decide which square is darker. Anybody have a guess? Which square is darker, A or B? Guys, just somebody answer, please. You say B, say B's darker? Okay. All right. Well, without guessing, without saying, all right, I know this is an optical illusion, which one looks darker to you? A. Okay. A looks darker. All right. They are, in fact, both the exact same color. Okay. But objectively, A looks darker to us. If you say it doesn't, then you're lying, okay? Because that's the illusion. All right. Why, if A and B are the same color, why in this picture, why do we perceive B as being lighter than A? Okay. All right. Our brain knows that's the pattern. So it's just what it expects. Right? Anybody else have a guess why we perceive B as being lighter than A, even though they're the same color? Yes. Okay. We see this shadow here, and basically what our brain does is says, oh, okay, that's the shadow that's making it darker, not the actual color of the tile. So our brain basically blocks out that shadow. Same idea. Do you all remember the dress controversy from a couple years ago? If it was like blue and black or white and gold. Yep. It's the same idea. Okay. However you perceive that dress is based on what sort of light you perceive around the dress. Okay. So whether you think it's inside or outside changes how you perceive that dress. Okay. So any questions there? I'm gonna watch a video here in a sec. All right. So can you have sensation without perception? Can you have information that comes into the brain, but your brain is not able to make sense of it? Hopefully, at this point in this class, you figured out when in that line of questioning, the answer I'm kind of leaning towards a certain answer. Yes, you can. An example of this is what is called prosopagnosia. Prosopagnosia is face blindness. Okay, we have two areas of the brain dominant in the right hemisphere, I think. But there's not like hard evidence for either. Two areas of the brain in the inferior temporal lobes, so right down back here, called the fusiform gyrus or the fusiform facial area. And these are areas of the brain that their sole purpose is to recognize faces, is to put faces together. All right. Because when we look at a face, if you think about it, and you've never thought about this, but when we look at a face, you don't look at the individual features of the face, right? You look at the face as a whole. Okay. And that's how we recognize people. All right. People with face blindness, like this guy that we're about to watch, don't have the ability to do that. The information comes in, but his brain is not able to make sense of it. And the way I could probably explain this, and this is really hard for any of us to imagine because none of us have ever experienced this before. But it'd be kind of like if you were able to look at letters in a word and you could see the individual letters, but you couldn't put them together to form a word. Okay, so you could see the individual letters, but you couldn't form the word from the letters. Okay, this guy can see the individual parts of a face, but his brain cannot put them together to form an actual face. Okay, so any questions before we watch this? It's pretty interesting. Huh? Well, sort of. Yeah, Gestalt is more of like organizational principles that we use in like they use it a lot in architecture, but like the idea that we see the totality of a face rather than the individual features is kind of is Gestalt. Okay, good question, good connection. All right, here we go. All right. Anybody got any questions about that? Yeah, I mean, again, this is like nearly impossible for us to imagine. But yeah, like he can see the individual parts, but he says there's some incompleteness there where he could like see the individual parts, but he can't put them together to be a recognizable face. He just he's lost that ability to. So this is a good example of what association areas do. Okay, this area is an association area. Um, he just has lost the ability to do that. Um, they actually think that there are a lot of people who are like mildly face blind and don't even realize that they are face blind. Because the really mild ones, it's just kind of like you might have a hard time remembering people's faces. And so somebody in here might be face blind and not even realize it. Okay, anybody else got any questions? Um, yeah, yes, that's probably a good one because he does say in that none of them look like anybody, and it is kind of like with squirrels, like they all just look like a squirrel. All right, you're not like, that's an ugly squirrel right there. Like you're just like, it's a squirrel. Okay, and so I guess it would be somewhat like that. Yeah. Okay. All right. Anybody else? Got two more concepts to talk about. All right. So the ways in which we perceive the world, the ways in which we process information, both of these are really important concepts. Bottom up processing. Bottom up processing is the process of forming a perception. Okay, we are basically forming perception. This thing isn't writing right now. All right, basically what it is looking at individual features of something, like a face. Like if we were to look at the individual features of a face and look at the mouth, nose, and then put it all together and say, all right, that is a face right there. That is bottom up processing. Okay, we would call this sensation followed. I'm going to just type it in here. So this is starting with sensation, information coming in, and then your brain, your mind forms an overall perception of it. We do this a lot as kids, little kids, babies. To learn about the world, what do? You have to watch them all the time because anything that they find, what are they going to do with it? Yeah, they're going to try to put it in their mouth, right? That's their way of building perception from sensation. They put it in their mouth, they realize maybe it doesn't taste good, it's blah, blah, blah. And from there, they learn about the world. Okay, we use bottom up processing when we are in new experiences. It's also called feature analysis. So, for instance, like, I like to analogize it to if you were to be given a puzzle, but without a picture of what the puzzle was. Okay, and if you're just given puzzle pieces and you had to put them together yourself to figure out exactly what the puzzle is. Okay, the scene from The Office when I think Jim gives Dwight like a piece of something like every day for Chris, and Dwight has to figure out what it is, and it's like a nutcracker or something like that. Okay, that is bottom up processing, building a perception from individual pieces of information. What we're doing right now, teaching and learning like this, is bottom up processing. I didn't know how to do this. I've been teaching for 10 years. All right. I've been a first year teacher this year. Okay. Having to relearn all this stuff. It's bottom up processing. Usually I would be able to just kind of walk in and say, like, all right, we're doing this, blah, blah, blah. No, I have to change up everything. You all have to change up the way that you learn. Okay. So Can anybody think of any other good examples of bottom-up processing? I can think of one right now that for all of you all, it is bottom-up, other than just learning how to learn on Zoom. Do any of you all have any prior experience with this information? Have you ever heard of bottom-up processing before? No. That's what you're doing right now. You are using bottom-up processing to learn psychology. Okay, so pretty much all the stuff in this class is bottom-up processing. Yeah, example I always like to use is I love to travel. I've traveled a lot. And some places you go to and you have an expectation of what it's going to be like. You go to Germany and you're like, all right, they're speaking German. They're like blah blah. There's some bratwurst. I knew they like bratwurst, like blah blah blah. Okay, but some places you aren't really able to form an expectation. And one of my favorite places that I've been went a couple of years ago is India. Um, and has anybody in here been to India? I mean, I figured that probably a lot of the Indian students have been to India. Yeah. So, is India? Where were you born, Adarsh? Where? Uh, oh, okay. All right. And those of you who have been, is India a lot like the United States? No, no. And like, there's not really any way to like mentally prepare yourself for it before you go. Because so like I took this picture on my first day there. We had taken the train from Gurgaon down to Old Delhi, and this is in Chandni Chowk in Old Delhi, and it's so vastly different that you get out of the train and you come out on the street and you're used to like a regular city, with people driving in lanes and whatnot. None of that. All right, cars are literally everywhere. Going, and there aren't really any driving rules. There are suggestions, but not really rules. And this is in the middle of one of the most densely populated cities in the world. There are animals just roaming around. There are sounds. There are smells. There are wires hanging down. And it is one of these like, holy crap! Like, there's no way, it's sensory overload, and there's no way to prepare yourself for it. You just kind of got to take it all in and build a perception of it. Okay, highly recommend if anybody here likes to travel, especially to places that are a little bit that take you out of your comfort zone. Go to India. I would go back to India in a heartbeat. But it is a wild place. Okay. All right. Any questions there about bottom-up processing? All right. Usually when we'd be doing this, I would have you all turn and talk to each other, come up with examples. I wish we could do that, but it'd be annoying to like go into breakout rooms every like 2 minutes. All right. The other type of processing that we do that by the time you're your age, as you learn about the world, okay, and start to build expectations and build experiences, most of what we do is what is called top-down processing. Now, top-down processing is, I would say, the most important term of this entire class. There are about 15 other terms that you're going to have to learn that mean basically the exact same thing. Top-down processing is essentially starting with perception. Okay. basing our understanding of the world on previous experience and expectations. So for instance, see if you can read this right here. Anybody know what it says? Yeah. How are you able to read that so easily? It just makes sense. Yeah. Because your brain, once you learn how to read, your brain just has expectations when you are reading of what a word is. Same thing, okay? You see here, okay? All of you all should be able to read this, unless you just don't know how to read, okay? Your brain just has an expectation of what the word is. You don't even think about it, but when you read, you don't look at every letter. You look at the first and last and say, all right, based off prior experience, I think this is what the word is. Okay? So this is what we do. Basically, top-down processing is a mental shortcut. And it's not always good that we do this. Stereotyping is top-down processing. Basically having an expectation of what a group of people is like is top-down processing. Okay? If you were to, this is my dad right here, and my dad was a very well-known lacrosse coach in North Carolina for a long time. He's in the North Carolina Hall of Fame for coaching. And I'm a coach as well. And we know a lot of the same people. Okay. But coaches knowing my dad could alter their perception of me. Okay. It's actually helped me, coaches that have known my dad, because they've been more likely to hire me, right? Because they say, oh well, Bill Hook Sr. was a great coach, and so I'm sure Billy Hook Jr. is good as well. Okay, that's top down. It's using top down processing there. Your ability to walk around your room in the dark at night and feel your way around is top down processing. How is that top down processing? All right, you make assumptions where everything is. Yep. Adarsh, what were you saying? Yeah. Okay. All right. You are basing it off of prior experience. Okay. So we're going to talk this is going to come up. We're actually next class. We're going to use a different term to describe this exact same thing. All right. But before I let you all go and do asynchronous, one more video. Okay, this is an example of top-down processing. This is an illusion. Illusions are all top-down processing because they are basically based off of our mind overriding the information coming in. All right. So top-down processes are dominant over bottom-up processes. What our mind expects to see is way more important than what it is actually seeing. All right. So this is a cool illusion. It's weird. All right. And it is a top-down process. So here you go. Okay, so why do we see the inside of the mask as being a regular face? Exactly. Yeah. Okay. That's why it's a top-down process. Even though the information coming in says it's hollow, your brain's like, well, no, it's not. That's not possible. Okay. We don't see faces like that. All right. So our brain just automatically flips it, and it's impossible not to see it. Okay. Unless, actually, this is weird. They've actually found a correlation with, huh? So somebody just asked a question. They found a correlation with people with schizophrenia are less likely to be susceptible to this illusion. And that could be because their top down processes don't necessarily work in the same way. All right, but it's just because our brain expects to see a face here and doesn't expect to see a hollow face, so it flips it. Okay, so anybody got any questions about that? Okay. I wish I could see people's reaction because I mean, this stuff is pretty cool. Um, it's not as fun doing it in here as it would be in class. Okay.